Okay, this is Unit 7, Lesson 1. What are equivalent ratios? Who can explain to the class? What are equivalent ratios? Is there a volunteer? And typically, throughout the morning, students try to use some of the words from the question to answer the question. Try to use different words. This scholar. That is good. If two ratios are equivalent, then they can form a proportion. That's correct, yes. And I like that. That's the first response I've had like that. That's correct, yes. Does somebody else have another answer? I'll give you an example. 1/2, 4/8. Those are two ratios that are equivalent, right? Yeah. So 1/2, 4/8. But why are they equivalent? Fatima. What's that? A half, you can't. Do you mean that you can divide the numerator and the denominator by a factor of 2? Well, 4/8 you could. 1/2, you wouldn't get a whole number in the numerator and the denominator. Trinity, can you help her out?
They both have the same multiple?
That's not what I'm looking for. They don't. Two equivalent ratios don't necessarily have the same multiple. Go ahead. Richard. They have the same. They represent the same amount or the same value. Does that make sense? So when we're talking about ratios and proportions, they represent the same value. If we're talking about fractions, they represent the same quantity. So the example I gave you was if I had half of a pizza, that would be the same as 2/4 of a pizza, right? I'd have 2 slices of pizza that I cut into 4 parts. Do you guys understand? Okay, so they represent the same amount, but with ratios and proportions, they have the same value. Okay, so moving along. Equivalent ratios have the same value. Now, find 2 equivalent ratios for each of these given ratios. Who can give me an equivalent ratio to 2/5? Go ahead, Samantha.
Okay, wait, 2 for each.
2, but if you got 1, I can get somebody else to give me the other part. Go ahead and give me the first one.
One that I did was I multiplied 2/5 by 10, and I got 20/50.
Nice, that's a good one. So you took multiplied by 10. Okay. And you got 20/50. Okay, that's an equivalent ratio. And here, everybody's going to have, you might have the same answer as somebody else, but remember there's infinitely many equivalent ratios. If you have a ratio, there are infinitely many ratios that are equivalent to that ratio. You guys remember? So who has another one? Makeda.
I did 2/5 times 2.
2/5 times 2? And what did you get when you did 2/5 times 2?
4/10.
4/10. That's the one I picked. Okay, by a factor of 2. 2 times 2 gave me 4. 5 times 2 gave me 10. 4/10 is equivalent to 2/5. Who's got another one? Did anybody have this one? I multiplied by a factor of 3. So if I multiply my numerator and my denominator by a factor of 3, what do I get back? 6 over what? 6/15. Okay. All of these are equal. You might have some more, but these are all equivalent fractions or ratios. Okay. Who's got number 3? Who wants to volunteer for number 3? Nobody's got a guess? Akpana. Yeah, what did you get back? 26/100, because you multiplied by a factor of 2. Very good. So she took the original ratio and multiplied the numerator and denominator by 2. She got 26/100. Does somebody have another one? Yes, Sergio.
135 times when I multiplied by 10.
You multiplied by 10. So when you multiply by 10, you multiplied by 10, you got 130 over what? Over 500. And remember, we got to multiply the numerator and the denominator by the same factor. Okay, So if I multiplied by 2 to get this one, another easy one would be, if I wanted to use small factors, would be 3. If I multiply the numerator and the denominator by 3, 3 times 13 is 39, 3 times 50 is 150. There are more examples, but I want to move along. Who's got number 4? Caden, thank you.
I did times 5.
Okay, nice. Times 5, what did you get when you multiplied by 5?
The numerator is 15.
Okay, so times 5, when you multiplied times 5, you got 15. And what did you get in the denominator?
For the denominator, I got 125.
Well,
Hold up.
125, right. 125. Very good. Okay, who got another one? I like that you guys are picking some challenging ones. You're not just going with the easy factors. Makeda, give me another one.
I did times 4 and I got 12 over 100.
Okay, so you multiplied times 4, and I'm going to just go this direction. So times 4, this gave you 100, and this is going to tie in nicely to what we're doing for today, and you'll see what I'm talking about in a little bit. So you got 12 over 100, and so let me give you a couple others. 3/25, if I have a factor of 2, I get what? 6 over 50. Times 2 gave me 6, times 2, 25 times 2 gave me 50. And then if I multiply by a factor of 3, what would I get back?
9.
9 over what? We're talking about quarters here. If I got 3/4, how much do I have?
75.
So 9 over 75. Okay, we good? All right. Now, let's get on with the lesson for today. Like I said, for the semester, I feel like this is the easiest lesson or the easiest unit of the semester. Okay? What you'll learn, to model percents and to write percents using equivalent ratios. That's what we did in the warm-up. New vocabulary, percents. Okay? So a lot of times I try to get you guys to remember words, new vocabulary, with words that are similar in sound. Okay? So vocabulary tip. Percent means per 100. Okay? The root word cent appears in words such as century. How many years in a century? 100. Centimeter. Centimeters. How many centimeters does it take to make a meter? 100. And centipede. Centipedes are supposed to have how many legs? Okay. All right. Now, why learn this? Percents make ratios easier to understand and compare. You can use a percent to represent the floor space needed for each piece of furniture in a room. So here we have a blueprint, okay? And if you notice, how long is one wall and the other wall?
10.
How long is the length of this room? 10 feet. What's the width of the room? 10 feet. So a percent is a ratio that compares a number to 100. You can use a model to find a percent. You can model percent using a 10 by 10 grid. Well, a 10 by 10 grid, what's 10 times 10? 100. So in a 10 by 10 grid, there are 100 squares in that square. Does that make sense? So in this room, since my wall is 10, my length is 10 feet for one wall and 10 feet for the width, the number of square foot tiles that would fit in this room would be 100. Okay? And so down here, take a look. Using models with percents, the floor plan above shows a bedroom with an area of 100 feet squared. Now, remember, we can treat units the same way we would treat variables. So 10 times 10 is 100. And then feet times feet to the second power. Remember, the exponent tells you how many times you multiply it to itself. So if I multiply feet to feet, I've multiplied it twice, so the exponent is 2. Do you guys see why it's feet squared? Okay. Find the percent of floor space needed for each piece of furniture. Well, if you take a look, let me move this up just a little bit. If you take a look at the bed is how wide? How many squares across is it?
1, 2, 3, 4.
It's 4, right? And then how long is the bed?
8.
This would be how many? And then that many more. So how long is it? Recount. 7. So if the width is 4 and the length is 7, how many squares would make up 28? 4 times 7, 28. So 28 of the squares in the entire room would be taken up by the bed. So 28 per 100, or 28 out of 100 of the squares. So how do I write that as a percent? This is the easiest one to do. Savannah? 28%. Okay? So when you have 100 in the denominator, that's the easiest fraction to convert to a percent. Do you understand? And we're going to try to use that as a shortcut with some other ones. So over here, if you take a look at the desk, we could count how many squares take up the desk. How many squares take up the desk?
4.
Well, it's 4 is the length, but how wide is it? It's 2, right? So if it's 4, if it's 4 by 2, how many squares altogether make up the desk? 8, because 4 times 2 is 8. So we have 8 per 100 tiles. And how do we write that as a percent?
8%.
Super easy, 8%. Okay, now, first period and second period. They're like, Mr. Headley, what is a bureau? It's just a fancy word for a dresser. That's it. So over here we got a bureau. And the bureau is, how long is the bureau?
5.
5. And how wide is the bureau? 2. So how many squares does the bureau take up? 10 square feet. So we have 10 per 100 squares. So what's the percentage of the room that it takes up? 10%. All right. Just so we're not confused, because some of the students were confused about this right here, this like quarter of a circle. What does that represent? Does anybody know? Akfana, what does it represent? This part right here, is that anything? What is it? Okay. Savannah, you got a guess?
I think it's like how far the door opens.
It's actually, it would be the door, right? And this would be the swing radius of the door. So it's just how it would be represented in a blueprint. If you had a house, you would see that for every place there is a door opening. Does that make sense? So it doesn't really take up any square feet. Okay? It's just showing you where the door is in the room. Yes?
Is that like basically what we do for the portfolio?
Yes, that's a good point. So in the portfolio, that's what you're doing. It's easy, right? And just a little reminder, portfolio is officially due tomorrow. If you guys get it to me before break, I won't take points off. I won't tell anybody that you turned it in late. But if you don't turn it in to me next week, sorry. It was due tomorrow. And I try to be nice, and some of you want to try to take advantage of that. So I'm telling you right now, it is officially due tomorrow. Okay. Any other questions about this? Any questions? Okay. Now, using models with percents. Now, I know you guys, I don't want you guys to spend a lot of time making this 100 square grid, okay? I just want you guys to see how we're going to go about this, okay? So, again, it's 10 by 10s for this grid, right? The problem asks for us to model 25%. Can somebody explain to us how would we model that? Makeda?
You would shade 2, like one block of 10.
Okay, so you would shade one column of 10s?
Yes, 2.
Okay, so 2 columns of 10 would be 20, right?
And the next column only shading 5.
So then we'd only shade 5 over here, and that's what we get. Does that look right?
Yeah.
Okay, is that the only way I could have shaded it? So some of the other class said, hey, Mr. Headley, could I have just shaded like 5 by 5, a quarter of it this way? Yes, you could have. They would have both been accurate ways to represent 25% on the 10 by 10 grid. Now, moving along, let's do this one really quick. Model 80% on the 10 by 10 grid. How am I going to shade that? Fatima? We're going to shade in 8 columns because each column has how many? 10. Boom. Okay, now, here's what I need you guys to do for this problem right here. Read this very carefully. So far, when I looked at the tests that you guys took yesterday, I noticed a trend. This is what I noticed. The problems that didn't have words, they didn't have that wasn't a word problem, people did better on those than the word problems. As a matter of fact, I remember looking at a couple students where they got all of the multiple choice problems correct except for the word problems. So that tells me we need to work on our comprehension. And I've been saying that all along. So what I need you to do, I don't want you to discuss with anybody. This is about what you can comprehend from that question right there. You need to read that question. You need to decide yourself, what is it asking me to do? Then you need to come up with a plan to solve the problem. And then you need to work it out and solve your problem. Once everybody's had time to do that, then we'll discuss it. That's when I'll take your questions. So, I'm looking around. I see some people are thinking about it. I see some people are already off and running. They're writing something down. They've got a plan of attack. When you think you've solved it and you've worked the problem out on your paper, if you could put your pen down or your pencil down so we could start discussing the problem. So there's two ways to go about this. One way is a little faster than the other. Who can share with the class their strategy? Denia? Even if you don't have the answer, can you tell me like what ideas do you have here?
So all the percents that we gathered from the bed and the desk and everything, we should add them all up and divide it by the amount of space we have in front.
Okay, so what was the bed? Do you remember?
28.
28%. Okay. And then what was the bureau?
10.
Yep, that was 10%. And then what was the desk?
8.
That was 8%. So you took all those and you added them up. So we took 28 plus 10 plus 8. We added all that up. And what do we get back when we add all that up?
46.
Well, don't forget to carry. 8 and 8, 16. Carry the 1. Yeah, you're right. 46% total for the room, right? Okay, so what did you do with that information once you had all that?
I subtracted it from 100.
So you took 100. That was the total size of the room, right? The floor space of the room. So you took 100.
Please pardon the interruption, teachers and staff. The book fair is open to students who would like to purchase items.
Minus 46.
Please only send one student from your class at a time and have them with a pass.
And then what'd you get when you subtracted all that?
You are able to send down students who want to purchase
54. So
book fair.
if
Thank
we
you.
regroup, this is 10, but not until we make this 9, and that makes that 0. So 10 minus 6 is going to be 4. 9 minus 4 is going to be 5. So 54% is what is unused floor space. Okay. So okay. So what you could have done was Denia's strategy. I noticed just looking around the class, some of you guys were trying to count the floor tiles that weren't covered up by furniture. That's the long way. But do you guys understand Denia's method?
Yeah.
Okay. So she used some information that she knew, and then she used it to solve this problem. Okay? Any questions about this? We're good? Easy so far, right?
Yeah.
Now we're going to get to what's even easier. We've been doing this all along, so watch this. Equivalent fractions, equivalent ratios. We've been doing this for a while. Okay? Now, factors of 100. What are some numbers that go into 100 without having a remainder? What numbers can divide into 100 without a remainder? 10, because 10 times 10 is 100. What else?
5.
Kimberly, 5. What times 5 gives you 100? Can somebody help her out?
20.
20. 20 times 5 is 100, right? Any others? Leonardo? Yeah, we just said, well, we got 20 because she gave me 5. We know 5 times 20. Does anybody got another one? Sergio? 4. 4 times what gives me? 25. So I think we've got most of them. You forgot 1, right? And then, okay, 50. 50 times what? 2. So here's the list of factors. So the factors of 100 are 1, 2, 4, 5, 10, 20, 25, and 50, and then obviously 100. Okay? Any ratio written as a fraction with the denominator that is a factor of 100 is easy to write as a percent. So listen, you saw how it was really easy when the denominator was 100 to write as a percent. That was what we did in our warm-up. You guys looked at it and said, oh, that's easy. The bed was 28% because 28 out of 100, right? And then we saw that the desk was 8% or 10%. No, it was 8% because 8 out of 100. And then we saw the bureau was 10% because 10 out of 100, right? So you're not always going to see a ratio where the bottom number is 100. But if you see a ratio that has the bottom number 1, 2, 4, 5, 10, 20, 25, 50, or 100, those are the easiest ones to write as a percent because you can rewrite it as an equivalent fraction. So let's practice this. Here they are. Do you guys see it? Now, take a look at this. Finding percents using models. So let's just practice using models for now. If you take a look, do you see this first box? How many squares are in this first box? 100, right? And how many did we shade?
20.
We shaded 20, right? And that's super easy to write as a percent, right?
Yeah.
What's the percentage shaded? 20%, right? Now take a look at this. How many, we have a box, how many parts of the whole are there?
10.
There are 10. How many are shaded? 2. Right. So remember, is 10 a factor of 100? Yes. What can I multiply by 10 to get me 100? 10. So 10 times 10 is 100. But remember from the warm-up, if I multiply the numerator by 10, if I multiply the denominator, I also got to multiply the numerator. So what would my numerator be? 20. And so that should make sense. This is equal to 20 over 100, which is equal to 20%. And doesn't it look like the same amount of area is shaded? Does that make sense? Now let's look at this last one over here. How many parts of the whole do we have in this last box?
5.
We have 5 parts. We have how many of those parts are shaded? 1. So we have 1/5. Now, is 5 a multiple of 100? Is 5 a factor of 100?
Yeah.
Okay, what can I multiply by 5 to give me 100? It's going to be 20. So 5 times 20 is 100. So if I multiply the denominator by 20, I got to multiply the numerator by 20. What's the numerator going to be when I multiply it with 1?
20.
It's going to be 20. And we know 20 hundredths is 20%. Right. And so just like Makeda said, the amount that's shaded is the same for all 3 of my areas. Do you guys understand? Okay. So what you guys need to be prepared for, you might see it like this first example where the denominator is already 100. But if you don't, and you have a denominator that's a factor of 100, turn it into an equivalent ratio that's got 100 in the denominator. Got it? Then it's easy to write as a percent. So any questions about my example? Yes?
What happens if the denominator isn't
If it's not a factor of 100, we're going to get to that. So that's going to come up later. But I'm glad that you're thinking about, like, what about the other situation? We're going to get to that. So here's what I need you guys to do. I went ahead and gave you the ratio. I need you to find the percents. So if you guys can quietly work individually to see what you know. You're very anxious to share with the class what you know, but I want to make sure everybody has an opportunity to try. So I'm going to assign some problems to some students. Audrey, could you do the first one? And the second one, could I get Trinity to do the second one? And then the last one, Lauren, I haven't heard from you. Could you do the last one? Okay. So continue working. You three students, I would like for you to explain those problems specifically. Audrey, can you walk me through your problem? So first of all, is my denominator a factor of 100? Okay, so 4 is a factor of 100. What can I multiply to 4 to give me 100? 25, very good. So if I multiply 4 times 25, I get 100 back. So what happens when I multiply 3 times 25? What do I get back?
75.
What is it? It's 75. And so my percentage is 75%. So it sounds like you have a question. What's your question? Do you understand now what happened? So 4 is a factor of 100, okay? And 4 times 25 equals 100, right? So if I multiply the denominator by 25, I have to multiply the numerator by 25. Otherwise, I don't have an equivalent fraction. So she did the same thing to the numerator and the denominator, and that gave me 75 over 100, and that's easy to write as a percent, so 75%. Do you have a question?
Another way to think about it is that 4 quarters equal $1, which is basically 100.
Right.
Take away 1 quarter, 75.
Do you know why they call 25 cents a
Ms.
quarter?
Marine, if you could please report to the front office. Ms. Marine, if you could please report to the front office. Thank you.
Do you know why they call 25 cents a quarter?
That's a quarter of 100.
It's a fourth of 100, a quarter of a dollar, a fourth of a dollar, right? And if we have 3 quarters, how much money is that? 75 cents. So a lot of you are pretty good when it comes to like thinking about money, but that's what math is. So usually when you tie the numbers into what you know about money, then it's a lot easier, right? So that's a good observation. Who had the next problem? Trinity, can you walk me through this?
Okay, so there was a factor of 100.
Yes.
I multiplied it by 50.
Very good. 2 is a factor of 100. If I multiply 2 times 50, that gives me 100. What do I multiply the numerator by? 50 also. And so what's the numerator going to be? 50. So what does my fraction end up being? 50 over 100. And that's super easy to get the percentage of, right? 50%. And then the last one, Lauren, are you good? Walk me through this, Lauren. Look at the denominator first. Okay, is the denominator a factor of 100? Yes. What do we need to multiply 10 by to give me 100? 10. Okay, so we're going to multiply the denominator by 10, and that gives me 100, but whatever I do to the denominator, I also have to do the numerator, right? So what's my numerator going to be? Nice, 70. So then, super easy, 70 over 100, which is 70%. Okay, are we good? It's not always going to be this easy, but we're just starting a new unit, and we're going to start out like, hey, this is one strategy to get this done. Moving along. All right. Listen, this word problem has 2 ways to solve it. What I need you to do is read it and be careful. Read it, comprehend it, come up with a strategy to solve it, work it out, and then we're going to share with the class your answer. This morning I had 2 ways of getting the correct answer. Good. It looks like every single person here is trying to get this. I'm curious what your strategy you used. Can you walk me through this? What are you thinking when you read this? What's the first thing? What's your strategy? Okay, we'll just start somewhere. You gotta try. Perfect. That's where a lot of kids messed up. So you got what I thought was the hard part. So the first thing you gotta do is they want the percent correct, right? Okay, but there's another method that you can go about it. So that's the first thing. So you're on the right track. Okay? Do you see why I put 20 in the bottom? Why did I do that? Because that's the total, right? Okay, we're trying to figure out the numerator, which is what you said. What's the numerator going to be? Right. All right. So now it's just like what we just did. It's just like Audrey Lauren and Trinity's problem. Right, the factor of 5 takes my denominator to 100, so then I'll know the percent correct. So what's it going to be? Figure it out, finish it up. So what do you think it's going to be? What's the percentage correct if they got 17 out of 20? 85. Nice, 85. Do you guys agree?
Yeah.
That is correct. Let me go ahead and put the note in here that we multiplied the numerator and the denominator by 5. And we got 85%. Now, can I share with you guys an alternate strategy? Did anybody have another strategy? What was your strategy?
I did 3 over 20 times 5, so I got 15 over 100.
So she took 3 over 20. This is the percent incorrect, okay? And then she saw that this is 15 over 100. And so that equals 15% incorrect. Okay? So you have to be careful on these problems, what they're asking. So that's the percent incorrect, but we can still use that to get the correct answer. So altogether, if I got it all correct, how much would that be? 100%, right? So if I take 100%, didn't miss anything, and I subtract 15%, what's 100 minus 15? Well, I got to borrow that 0, becomes a 10. This becomes a 10, but I had to borrow to make that a 10, so that goes away. 10 minus 5 is 5. 9 minus 1, 8. 85%. Isn't that what Jabari just gave us?
Yeah.
So do you understand the alternate strategy? Okay. Now, that was the example in the book. That one's a little more challenging. You have to be careful when you read the question. Here, I have no doubt in my mind that you guys can get this problem now. Read it, comprehend the question, come up with a strategy, and then I would love for somebody to share their answer with me. I don't think I've heard from Leonardo today. That face you gave me reminded my son when he had to go in his diaper. He gave me that face. So did you get a ratio? What was it? Come up with the ratio. What's the ratio you got to start with? No, that's not how it works. Try it again. Okay, so walk me through it. What's the first thing I got to do? Okay, that's one method that you can use. Okay, so what did you get? You took 25 and you subtract 20, and then what do we get back? 5. Okay, now what? What's next? Yeah, what's our denominator going to be? Right, so we have 5 out of 25. Okay, now what? Okay, you're going to multiply by what? So if you had a quarter, how much do you need to get to 100? I'm talking about money now, because people usually understand money. I got a quarter, I need to get to $1. How many quarters do I need to get to $1? Because $1 is 100 cents. A quarter is 25 cents. That'd be $1.25 if I had 5 quarters. Very good. So to get to 100, I need to multiply by 4, but I can't just do that to the denominator. So 25 times 4, like you said, is 100. Okay? And what's 5 times 4 going to be? 20. So that's 20%, but this 20% is talking about what? Is that talking about how many we won? What did you just find? The percentage we won, or what's if we're either winning or we're what? We either won or we tied or lost, right? So this would be 20% lost or tied. Lost or a tie. Okay? But if that's 20% how much we lost or tied, how do we figure out how many we won? What percentage do we win? Think about what we did up here with our alternate method. Going to subtract 20% from something. 100%, right? So if I take 20% away from 100%, what do I get back? So 0 minus 0 is 0, and then 10 minus 2, what's that going to be? So what we get back is 80%. Now, this is kind of like, that's doing a lot. I brought the alternate method up because a lot of students wanted to go about it that way. I'm going to say you can get to the answer that way. The easy way is saying, look, it's asking for how many wins we got, what percentage wins. So we take 20 over 25, 20 over 25, okay, and then, Leonardo, we're going to see we get the same answer. Using the same strategy you use, I need to go from 25 to 100 by multiplying by 4. 25 times 4 is 100. 20 times 4 is 80. 80%. That's the wins. %, we won. Okay? So the alternate method, a little bit extra. I'd prefer you do it that way. Yes?
So for homework, do you want us like to label it like for like the if we have a question like you want to label what the wins is and what the
Well, if it's asking for the win, I don't need you to find the losses and then subtract to find the win. That's one way to get there. That's the long way. I prefer you do it the fastest way possible. Okay? Moving right along. Last slide. We're almost done. Write a ratio and a percent for the shaded area in the diagram. So here's my diagram on the left. The shaded area is shaded in yellow. Who can tell me how they went about figuring this out? It's a 10 by 10. I need a volunteer to explain this to me. Savannah, yes, go ahead. What is the ratio from that model?
The ratio is
32. How did you come up with 32?
because I see 3 of the
You see 3 columns, and each column is how many? 10, right? So yeah, that's 30, and then you see 2 extra change, so 30 plus the 2 is 32. So 32, what's the ratio going to be? 32 over 100, and what's the percent going to be? 32%. Very good. Okay, any questions about that? All right. Here's another question. This is already brought up earlier, but model 80% on a 10 by 10 grid. How much of it am I to shade in? Somebody walk me through this. Somebody explain this to me. Maya. 8 what? 8 columns, because because each column is worth 10, so we're going to shade in 8 columns. Very good. All right, so remember the strategy that was used and demonstrated by Audrey, Lauren, and Trinity? You're going to use that right here, right now. Make sure we got this. Okay, now I want you to do the middle one. Samantha, can you do the last one? And who can do the... Melvin, can you do the first one? Melvin, what's the answer to the first problem? 67%. 67%, very good. Okay, who's got the middle one? Go ahead, Caden.
Alright, so first you have to multiply 5 times 20.
Right. Okay, is that all? Am I done?
No, you have to do the same with the numerator.
Very good. Do the same thing in the numerator. All right. So what do I get back?
You get 80 on top for the numerator and 100 on the bottom.
Right, and
that
that's
equals 80%.
80%. Nice. Okay. Last problem.
Okay, so first I looked at the denominator and I said I could multiply that by 10.
Okay.
By the top by 22.
Okay, you saw that we can multiply the numerator and the denominator by 10. Okay. So what do we get back?
90 over 100.
And then what percentage is that? 90%. Very good. Okay. Super easy lesson, right? All right. Now, last question, and we are finished. How can you use percents to compare two ratios with different denominators? So we need to compare two ratios. How can we use percents to help us compare them? Makeda.
This is percent self-discipline because, like previous problems, like 4 times, well, not good.
Okay, you're on the right track. Figure out a better way to say what you're saying.
That's 28 over 100. And
So we wrote the ratio. What's the ratio? What's 28 over 100?
28 over 100 is 20%.
Right, so you took the ratio, you made it a percent, right? So if you have two ratios, you could just make them into a percent and compare the percent, right? Boom. Right, each ratio has a percent and compare the two percents, right? So in that room, what took up the most percentage of floor space? The bed. The bed did, right? And then what took the second most? The bureau, the dresser. And then what took the least? The desk. Easy lesson today, right? So that means that everybody's going to do their homework, right? Not just half of you are going to do your homework. Everybody's going to do their homework. Good job today.